Good day, this is Professor Will, CBMD PhD. Today is Saturday, June 5th, 2021. It is 1:24 and 10 seconds a.m. Eastern Standard Time. Today's research, new style interferometer. So let's hop to it here. An atom chip interferometer that could detect quantum gravity. Date June 4, 2021. Source, University of Groningen. Physicists have created a quantum interferometer on an atom chip. This device can be used to explore the fundamentals of quantum theory by studying the interference pattern between two beams of atoms. Physicists describe how the device could be adapted to use mesoscopic particles instead of atoms. This modification would allow for expanded applications. The device which scientists first proposed 100 years ago by German physicists. Their original aim of creating an interferometer with freely propagating atoms exposed to gradients from macroscopic magnets has not been practically realized until now. Numerous experiments have been done using photons, but never with atoms. Researchers created an interferometer on an atom chip which can confine and/or manipulate atoms. A beam of rubidium atoms is levitated over the chip using magnets. Magnetic gradients are used to split the beam, according to the spin values of the individual atoms. Spin a magnetic moment that can have two values, either up or down. The spin up and spin down atoms are separated by a magnetic gradient. Subsequently, the two divergent beams are brought together, again and recombined. The spin values are then measured, and an interference pattern is formed. Spin is a quantum phenomenon, and throughout this interferometer, the opposing spins are entangled. This makes the interferometer sensitive to other quantum phenomena. Researchers previously proposed an experiment to determine whether gravity is in fact a quantum phenomenon using entangled mesoscopic objects, namely tiny diamonds that can be brought in a state of quantum superposition. It would be possible to use these diamonds instead of rubidium atoms on this interferometer. However, this process would be highly complex as a device, which is currently operated at room temperature, would need to be cooled down to around 1 Kelvin for the mesoscopic experiment. Free fall if this is realized. Two of these atom chips can free fall together to neutralize external gravity, so that any interaction occurring between them would depend on the gravitational pull between the two chips. Researchers aim to determine whether quantum entanglement of the pair occurs during freefall, which would mean that the force of gravity between the diamonds is indeed a quantum phenomenon. Another application of this experiment is the detection of gravity waves. Their deformation of space-time should be visible in the interference pattern. The actual implementation of this experiment is still a long way off, but the researchers are very excited now that the interferometer has been created. It is already a quantum sensor, although we still have to work out exactly what it can detect. The experiment is like the first steps of a baby. Now we have to guide it to reach maturity. Good day, this is Professor Will, CBMD PhD, on Advanced Engineering, Space Science, and Astrophysics. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.